Okay, now we are given a function f of x is equal to 3x squared plus x minus 14. And suppose we ask you to find the x-intercepts using the quadratic formula. So here we have to understand what is the quadratic formula exactly. Now, we can use the quadratic formula only for the general form, okay? So the general form, again, let me remind you, is f of x is equal to ax squared plus bx plus c. So suppose I have this function, the ax squared plus bx plus c. Now taking the quadratic formula to find the values of x, which is your intercept, will be given as follows, okay? So minus b plus or minus square root of b squared minus 4ac, and all this divided by 2a, okay? So this plus or minus is actually going to give us both values of the x-intercept, okay? So we're using the quadratic formula to find the x-intercept. So, and the values of a, b, and c are the values of a here, b, and c. Okay, so let's try to find the x-intercepts from this function. So I have here minus b. So in this case, b is just simply 1. So I have minus 1 plus or minus the square root of b squared, so 1 squared, minus 4 times 3 times minus 14. So my value of c is minus 14. And all this divides 2 times a, where a is just 3. So let's solve this. I have minus 1 plus or minus. Here I have the root of 1. Now minus 4 times 3 times minus 14 will actually give me 168. So I'm going to have plus 168. All this divides by 2 times 3, 6. So I will have one value of x, so I can call that one x1, as minus 1 minus the root of 169, and all that divided by 6. And I will have x2, which will be minus 1 plus root of 169 divided by 6. So as you can see, we have a difference between this and this, okay? So that's how we're going to be able to find the difference between the two values of x. So I have minus 1, and the root of 169 is simply 13. So minus 13 divided by 6. And here I have minus 1 plus 13 divided by 6. So minus 14 over 6, or minus 7 over 3. And here 12 over 6, which is just, 2. So my two values, or my two x-intercepts, are going to be minus 7 by 3, 0, and 2, 0. And that's how you find the function, the values of x as x-intercepts using the quadratic formula for a given function. I could give you a second example. Suppose now I have f of x is equal to x squared minus 9. Now, here we already have an idea by using the difference of squares that this is equal to x minus 3 times x plus 3. And since this is the factored form, then I know that the values of 3 and minus 3 will be my x-intercepts. However, suppose I had a more complicated, instead of 9, we had 184, okay? But for now, just for the purpose of understanding the quadratic formula, I will just use x squared minus 9. But here I don't have a b. I only have a and c. Why? Because f of x, as we know, is a x squared plus bx plus c. So in this case, a is going to be 1, b is going to be 0, and c is going to be minus 9. Okay? So let's use the quadratic formula again. So I have minus b plus or minus root of b squared minus 4ac by 2a. And by the way, underneath this root is what we call the discriminant. Okay, discriminant. So now b is 0, so this is going to make things a lot simpler. I'll have 0 plus or minus root of 0 minus 4 times minus 9 times 1, okay? And then all this divides 2 into 1. So I'll have x1, which will be 0 plus, and then I could already figure out what this is. 0 minus 4 times minus 9 is 36. So I'll just have 36 divided by 2. And x2 will be 0 minus 36 divided by 2. Okay, last time I used x1 is equal to 0 minus root 36 and x2 0 plus, but it really doesn't matter. As long as you have two different ones. Okay, so here, continuing, I'm basically have a root of 36, which is 6 divided by 2, so 3. And here I have minus 6 by 2, which is minus 3. So my x-intercepts are just 3, 0, and minus 3, 0. And that is all. So you can use this formula, the quadratic formula, in order to find your x-intercepts for any given function that has the general form.